So as a continuation of that structure analysis, we'll just consider the same structure and try to get one example about reliable design example. So the question here that we're gonna ask is, when diameter of rod BC is 20 millimeters, so rod BC has circular cross section and diameter is 20 millimeter. If BC is made of steel, the allowable stress is 165 megapascal. So I will give you the definition of allowable stress in later lectures. But anyway, the allowable stress must be defined as the value similar than the ultimate strength of the material, and I'll talk about the reason why in later lecture. But anyway, the question is it gives us guideline stress and ask if it is safe. Okay, so if somebody give us the guideline stress, the stress that material is the material have is must be smaller than this guideline stress. Okay, that's the idea we have. So let's try to get the numbers. The force acting on rod BC is 50 kilonewton, and the area of this circle is, if we plug in d over 2 as radius, the area turns out to be pi times 10 to the negative fourth power square meter. Okay, so if we obtain normal stress after plug this into a calculator or Google search window, what you're gonna get is 159 megapascal. Okay, so this is the actual normal stress that rod BC is subjected to, and it's similar than allowable stress 165 megapascal. So we can say this is safe. Okay. So when the rod BC is 20 millimeter, and if BC is made of steel, and we can say that this is safe. Okay. So yeah, please note that this is a new kind of problem that you have never seen until ME231, like back in freshman physics and back in high school physics, because you only consider rigid body, non-deformable body. Yeah, you didn't have any problem like this. Okay, now let's twist the problem again and solve another problem to make a safe rod BC out of aluminum. So they changed the material. How large D should be, how large the diameter should be. Here, the allowable stress for aluminum is 100 megapascal. Okay, so of course it must be smaller than steel. So because this is allowable stress is 100 megapascal, if we keep the diameter as 20 millimeter, same as before, you can see that the stress is much higher than the allowable stress, and the structure is not safe. Okay, so we have to solve one equation, which is our normal stress F or A must be similar than allowable, the guideline stress of aluminum. So, and if we massage this equation, A must be larger than F over sigma allowable stress, and F is 50 kilonewton out of freshman physics statics problem, and allowable stress is 100 megapascal. The area must be larger than 5 times 10 to the negative fourth power square meter. Okay, and if you plug in pi r square is A, R must be 12.62 millimeter, and diameter must be 25.2 millimeter. Okay, so you can see that the diameter for aluminum rod BC must be larger than steel rod to make the structure safe. Okay, so you can see that depending on the material choice, you have to use different size of the rod to sustain same force, which is 50 kilonewton. And this kind of new degree of freedom, like a choice of the material, now enters into our consideration of mechanics. Okay, so it gives our mechanics course a little bit more interesting feature, and hopefully you can enjoy this new feature of mechanics. Okay, so with this, let me finish day 1 lecture of ME231.